One of the most important applications of matrices is to solve systems of equations. Writing the system of equations in matrix form is step number 1. So the first matrix will be represented by A and is known as the coefficient matrix. Because it is filled with the coefficients of x, y, and z. The second matrix will be represented by x and will contain the variables. The third matrix will be represented by b and will contain the constants that the equations are set equal to. We always use capital letters to represent a matrix. It distinguishes them from the lowercase letters we use for variables. So, capital A, or the coefficient matrix, will be the coefficients of x, y, and z for each of the 3 equations. So we'll have 3 different rows with 3 columns: the coefficient of x, the coefficient of y, the coefficient of z. So the first one is 1x plus 1y plus 1z, so it'll be 1, 1, 1. Then we have no x's at all, so that's 0, 2, 5. And then we have 2, 5, negative 1. You have to be very careful and make sure you take the negative signs along. The variables are x, y, and z. They go in a column matrix because of the way matrix multiplication works. The fact that you work your way across this row and down this column, so that we'll have 1x plus 1y plus 1z, and so on. And then matrix B are what they're set equal to, the constants 6, negative 4, 27. So again, in thinking about how matrix multiplication works, the system of equations will then be represented as matrix A times matrix X times matrix B. So we just put them next to each other. The product of A times X gives us the left side of the equations, 1x plus 1y plus 1z equals 6. 0x plus 2y plus 5z equals negative 4. 2x plus 5y minus 1z equals 27. Or in shorthand, capital A times capital X equals capital B. Second step, so once it's in matrix equation form, we're going to solve that new matrix equation. Given AX equals B, we can multiply both sides of the equation by the inverse of A, provided that it exists. So first of all, remember that only square matrices have inverses, and this goes along with the idea that if you have 3 unknowns, you need 3 equations to be able to solve for them. So that we always have a square matrix here, and we can try and find its inverse. If the inverse doesn't exist, the system will not have a unique solution. But if it does exist, we're going to multiply both sides of the equation by the inverse. Please remember that order matters when you multiply matrices, so you have to multiply by the inverse on the left-hand side of both equations. So that you have A inverse times A, which is going to give us the identity, leaving us with just x. And then you have to do the exact same thing on the right-hand side to maintain equality, so you have to do A inverse on the left times B. The multiplication may not even be defined if you try and put it on the other side, and you won't get the right answers. So remember that if you take the inverse times the original, you get the identity matrix. Which is like 1. Furthermore, the identity times x equals x, because multiplying any matrix by an identity matrix of the appropriate size leaves the matrix unaltered. It's like multiplying by 1. So x is equal to A inverse times B. So this is the general principle. If you set up a matrix equation where you have A times x equals B, then x is always going to equal A inverse times B. And that's how we solve a system of equations. So we put them in matrix form, we calculate the inverse, we multiply by the inverse on the left-hand side of both sides of the equation. That cancels out A on the left-hand side, leaving us with the identity times x, or just the x matrix, the variables. And on the right, A inverse times B will give us the values of those variables. So let's finish the example from above. We have our matrix A times X equals B, and we're going to find the inverse of this matrix and multiply by it on the left-hand side of both sides of the equation. When we take the inverse of A times A, we should get the identity matrix, and the identity matrix times anything is just that thing, because it's like multiplying by 1. So we'll be left with our variables isolated on the left-hand side, and we just have to figure out what the inverse of A is and multiply that by B, and we should come out with these three values, 5, 3, and -2. Let's remind you of how you'll go about doing this on your calculator. Okay, so on your calculator, remember the matrix menu, it's here in light blue right above the X inverse button. So to get to it, we press second X inverse, and we need to edit our matrices. We need to enter matrix A and matrix B. So let's scroll over and hit edit. Matrix A is a 3 by 3 matrix. It's 1, 1, 1, 0, 2, 5, 2, 5, -1. And I'm going to quit out, so second mode quits out. And now I'm ready to enter matrix B. So again, to get to the matrix menu, I press second X inverse. I'm going to go over to edit. This time I choose matrix B. Matrix B is a 3 by 1 matrix, and it is 6, -4, 27. So then I'm ready to do the matrix multiplication with the inverse of A times B. So I go into my matrix menu, so second X inverse. This time I'm going to select my matrices from the names. So I want matrix A, and I want the inverse, so I press that X inverse button right there below math. So that's A inverse on the left times matrix B, so second X inverse. On the names column, choose matrix B. So that's the calculation I need to do. I hit enter, and it shows us our three values for the variables. X equals 5, Y equals 3, and Z equals -2. So remember, second X inverse is how you get to the matrix menu. Edit is where you're going to enter your values. Names is where you come to select them. And then we just perform the operation A inverse times B. So here's example 2. We set it up as a matrix equation. So 7, 5, -3, 3, -5, 2, 5, 3, -7 times X, Y, Z equals 16, -8, 0. Remember, this is matrix A times matrix X, and it equals B. So to solve for X, we want to do A inverse times B. So X, Y, Z is going to equal the product of the inverse of 7, 5, -3, 3, -5, 2, 5, 3, -7 times B, 16, -8, 0. So let's see what that gives us for X, Y, and Z. Into our matrix menu, so second X inverse, over to edit, choose matrix A. It is a 3 by 3. We want 7, 5, -3, 3, -5, 2, 5, 3, -7. So just take a second to double check that you've entered everything correctly to ensure you're going to get the correct answer. Quit out, go back into your matrix menu, over to edit, choose matrix B this time. It is a 3 by 1. You want 16, -8, and 0. Again, take a second to double check you've typed everything correctly. Then quit. Back to your matrix menu, from the names list, choose A. Say you want the inverse of that, times, back into the matrix menu, choose option B, so that we can perform the operation A inverse times B, and see that X must be 1, Y must be 3, and Z must be 2. Okay, so we can see then our solution. 1, 3, 2. It's always a good idea to check it, plug them in, make sure they really work. So 7 times 1 plus 5 times 3 minus 3 times 2. Does that give us 16? Yep. That one checks, so we check the second equation. If we check in the third equation, because remember, x, y, and z must work in all three equations. Yep, it does. So we know we have found the correct values of x, y, and z and solved this system of equations. So example 3, we start by writing it as a matrix equation. 5, negative 4, 2, negative 1, negative 5, 6, negative 1, negative 4, 5, times x, y, z equals 21, negative 24, negative 21. So to solve x, y, z will equal the inverse of matrix A times matrix B. So let's plug that into our calculator and see what we get for x, y, and z. Okay, so we go to second x inverse to bring up the matrix menu, over to edit, choose matrix A, it's a 3 by 3, so it's 5, negative 4, 2, and then it's negative 1, negative 5, 6, and then it's negative 1, negative 4, 5. So those are the coefficients of x, y, and z, and again, you should always just pause, make sure you've correctly entered the values. We can quit out, go back into the matrix menu, over to edit, this time select option B. It is a 3 by 3, we want it to be 3 by 1. 21, negative 24, and negative 21. And again, just take a minute to make sure that matches up with your equations and you haven't made a typo. Now we're ready to do the operation. So back to the matrix menu, from the names list, choose option A. Say A inverse times matrix B. So back into the matrix menu, choose matrix B from the names list. Hit enter and it'll tell you the values of x, y, and z. So we see that the value of x is 5, the value of y is negative 1, and the value of z is negative 4. And you should take a few seconds, plug those in for x, y, and z in the original equations and confirm that they really do work for all three and that you have found the correct solution for this system of equations.